Hello everybody, it's Ms Redmond here in my kitchen, and this is your October half-term super curriculum Science at Home video, and these practicals are all going to be based around ice. So if you do any of these tasks, please send me photos or videos or a quick email or something, or you could even write up a full report. I put some writing frameworks on Show My Homework, and if you do any of those things, you will get a wonderful, beautiful, super curriculum, superstar postcard home for doing a super curriculum task, and you'll obviously get pride points or college points depending on the quality of what you send in. So these are the three practicals that we're going to do. We're going to do coloured ice, melting ice, and sensing temperature. So if you want to pause the video now and go and get any of the equipment that you need to do any of these tasks. Okay, so first up is coloured ice. You're going to, here's one I made earlier. You're going to get some food dye and mix it with some water, and then pour that into a plastic bag or a paper cup or something and stick it in the freezer. This was done overnight, but you could probably get it done quicker. And all you're going to do is you're going to take the ice out of the bag, pop it into the water, and observe what happens. So this is relevant to the particles topic in year 7 because it's a change of state, and the food dye is also going to diffuse into the water. It's also relevant to the cells topic in year 7 and year 9 because substances move in and out of cells by diffusion, and it's probably related to loads of other topics as well. It also looks a bit spooky, doesn't it, because it's green coloured, so maybe you could do this for a Halloween thing. You could even get creative, freeze some Lego characters in there, or experiment with different colours. And you could take photos or videos. You could do a time-lapse video, that'd be really cool, and see what happens. So there you've got some crossovers with art, media and photography. The other thing to note is that ice actually floats on the water, and that is because ice is less dense than water. Now, we'd normally expect a solid to be more dense than water, so that's quite unusual. So you could explain what we mean by density. You could explain why a lower density causes the ice to float. If you're higher up the school, you could research hydrogen bonding and explain why water ice has a lower density than liquid water. And you could also research examples of this in nature. So, for example, if you look at a pond that's frozen over in winter, the top is frozen and underneath the water is still liquid. So sorry, my family are wandering around in the background, that's fine. So you could investigate that and research that. You could also think about the Arctic and Antarctic ice sheets or glacial melting, and how all of these things impact on the creatures in those environments. Farouk or other people in 7T, you could explain how this might be linked to the water cycle. That's something that you guys know about from primary school. So I was saying you could use a plastic bag for this. You could also use a washing up glove like Sarah Marie did a couple of weeks ago when she was investigating freezing at home. So you could have lots of different fingers of the washing up glove and see how that affects the melting, or you could have a whole hand if you're doing some kind of spooky Halloween thing. So there's loads of options with this experiment. Right, next one is about melting ice. You're going to need 2 plates of different colours, and I'm going to choose 2 ice cubes out of here that are roughly the same size, very roughly. Okay, for this experiment, all you're going to do is pop the ice cubes on the plates get your stopwatch and time how long it takes each one to melt. So for my version of this practical, my independent variable, the thing that I'm changing, is the colour of the plate. My dependent variable is how long it takes to melt, because that depends on the independent variable. And my control variable that I've tried to control, not very effectively, is the size of the ice cube. So you could research how or why the colour of the plate might affect how long it takes for the ice cube to melt, and I'll give you a clue for that one. It's to do with infrared or IR radiation. So if you're in year 10, you could link that to the electromagnetic spectrum. You could choose a different independent variable, so you could change the ice cube size. You could have a regular size ice cube, or you could fill a container with ice, pop that in the freezer, and see how the size of the ice cube affects the time it takes to melt, and explain that. You could, rather than having 2 plates, you could have one on a plate, and you could pop an ice cube into a glass of water and see if that has any effect on the time it takes to melt. Or you could change the plate material. So actually that's a control variable that I haven't controlled in this experiment, because I've got 2 ceramic plates, and one's got a nice smooth glaze and one's this IKEA sort of semi-rough glaze. So they're slightly different, but you could have a ceramic plate and a plastic plate, or you could have a ceramic plate and a metal tray. You could choose loads of different independent variables. So I have said that you can only change one variable at a time, or it will be an unfair test, but you could take up the challenge of designing an experiment where you change 2 independent variables and still keep it a fair test. So have a think about how you could do that one. And then whenever you've finished, you could think about the implications of what you've learnt for helping out with the cooking. So if you're anything like me, you store loads of food in the freezer. So how could what you've learnt help when you're thinking about defrosting food? So there's a crossover between science and food technology. Well, anyway, all cooking is chemistry, so that's a massive crossover between science and food tech. Okay, last experiment is about sensing temperature. You're going to need a bowl of ice water, a bowl of tap water with a bit of warm in, so a little bit warm, and a bowl of fairly warm water. The key is that you've got 1 cold, 1 hot, and 1 in the middle. And you're going to put your hand into the hot and the cold one. The cold one really is uncomfortable, so you don't need to stay here for super long, but you do need to stay there for long enough for your hand to get used to the temperature. Okay, so this experiment is linked to the cells topic, because nerve cells take signals about temperature all around from your body to your brain, and my brain is sending me a signal to take my hand out of the ice water, because that is not nice. So that's relevant to the cells topic in years 7 and year 9. And if you're in year 10 or above, or you fancy a challenge, you could tell me if this is a reflex arc or not, and explain why. And if you think about it, freezing stuff is sort of the opposite to burning stuff. So that might be relevant to somebody in my class. Naming no names. So sorry if you didn't get a name check in this video. I'm going to do 6 of these, so you might get a name check in another one. And if you have any suggestions or requests for future videos, please let me know. Like I said, you will get a college point or a pride point and a beautiful postcard home if you send me any information about having done one of these experiments. Okay, so once your hands are nice and used to those temperatures, you're going to take them out and put them in the middle one. Ah, that's nice. And I'm not going to give away what happens because I want you to find out for yourself. Okay, that's all from me. Thank you very much for watching, and I will see you in school. Bye bye.